So what's up everyone? Welcome back. So today I built something honestly really cool. It's an AI recipe maker that runs completely on your local machine. No APIs key, no other stuff, no monthly subscription, no sending your data to some random cloud server, just in your local server, just in your local PC. So you just type in whatever ingredients you have at a home, choose your preference, and local AI model running on your own computer generates a full recipe for you. Okay, so I'm talking step by step instruction how I made it, and first of all, just tell you cooking time, serving steps, even a food image fooled automatically. So I built these features in it, and the craziest part, the AI runs offline or your GPU using tool called Olama. Okay, so you guys everyone know about Olama, I think. Olama is a open source AI LLM models. You can download it in your local and use it. So let me show you how I built this the tech stack, how the local AI connection works, how GPU acceleration makes it fast, everything. Let's get into it. So here's how the application works. You land on a hero page, click start cooking. You can get uh, this into ingredient panel, and you type whatever you have, like eggs, chicken, cheese, whatever you have. Okay, and add it. Like I added this four ingredients in it. You can type it. It's automatically suggest. I add some ingredients in it. Okay, so after it you choose language, but language feature is quietly not working, so we can just leave it as it is. We have to choose a different cultural food, like I choose Italian, Mexican, Indian, whatever I want. So I choose Indian. After that I have to choose the difficulty level, like I have to make it easy, medium or hard, so I choose medium as well. I have to choose cooking time, so I choose around 30 minutes. I have to cook 30 minutes. I got my recipe. Okay. So and I choose dietary. This is optional. So I choose vegetarian and click on generate recipe. So it took around 15 to 60 seconds. Okay, on internet fast. How's your internet working? And AI starts to make it like it is a local machine. I show you the GPU usage. This is my 3050 NVIDIA RTX, and it's a 6 GB integrated GPU memory. Still, I have a 2.5 GB AI model, but it it uses around 58 to 60% of 3050. So you can imagine like how why the people buys the Mac Mini and something for the servers. So that's the reason. This is only the 2.5 GB LLM model. I run it on the I'll I run it on the local machine. So that's the power of LLM model. Okay. So around in 30 second or 60 second our recipe are ready. You can check all the instruction, all the ingredients, all the tips of it. So I have to make a connection, like how your local LLM and your browser calls each, how connection works each other. So the backend is in Node.js with the Express, and you might ask why do we even need a backend if the AI is local? Because we don't want the front end directly talking to Olama. The backend handles the input, validation, sanitization, and rate limiting. Rate limiting is the perfect part of this project because you need to learn rate limiting in this project. If you you write a code from the AI and uh, it's not happened. But if the AI makes it 10 APIs per call, like I have just made a one API call and it took around 50% of 30-50. So you can imagine how the 10 API works parallelly. Okay, so you have to learn rate limiting in the backend for running the local model. I have added an in-memory rate limiter that caps request at 10 per minute per IP, so you don't accidentally over your own machine. Okay. The backend also handles calling the AI service and fetching recipe images. Now the stars of the show, Olama. Let's talk about Olama. Olama lets you run large language model locally on your computer. By default, I'm using Llama 2, but you can switch to Mistral, Gamma, Kimi, Code Llama, etc. Okay, so Olama runs a local HTTP request, not HTTPS. Servers on your port 11434. I'll show you. This is the port. Okay, and once you install it and a Pula model, it just sits there waiting for your request. When the app starts, the backend checks if the Olama is reachable. That's how the green or red status indicator shows up in the navbar. So that's our project, which is you have to test AI. Like in the era of AI, you have to make this type of project so you can imagine how AI works. When you generate a recipe, the backend sends a post request to Olama with a model name, with a prompt, with some options like temperature, top up, max tokens, something like that. We have a zero API cost, we have unlimited recipe, whatever you want to make, just type ingredients, select some options, and boom. Temperature controls creativity, 0 is robotic, 1 is chaotic, I set it 2.7 creative, but still sensible for recipes. Okay, so that's my project. And when we talk about GPU usage of that type of a model, so just talking to it, when you install Olama, it automatically detects your hardware. If you have an NVIDIA GPU, it usage CUDA. It's I don't know the exact meaning of it, but it's some kind of software detectable. And if you are on Apple Silicon, it uses metal. So if no GPU is found, that's fall back to CPU. But this type of models, I can't imagine how CPU works in it. When you hit generate, the model waits load into a GPU's VRAM for 7 billion parameters. It's around 7 billion parameters model. Okay, we have a 52 billion parameters model. Just imagine how many type of hardware we need to run this 52 GB of uh, Olama model. You need around 4 to 5 gigabytes of VRAM for quantization of it. So that's our project. I hope you like it and you learn many things in it. So that's it.